Hey everyone, I got a cool project here I'm going to be working on for a little bit as it is. I've got a handful of these Kurzweil K2000 series synthesis modules. So these are very cool and very powerful modules. They're both sample playback units, but they're also true synthesis engines. And I'll get into that a little bit more here in these videos. So Kurzweil made both keyboard and rack versions of these units. I'm only going to be talking about the rack versions here because that's what I have. So as you can see, I've got a bunch of them here. Two of them are actually mine that I've had for quite a long time. The 2500 RS I've got here, along with this 2000R. I've had these for a number of years. I've really enjoyed using them, and I've been wanting to go through and do some repair work and upgrades on them. I just haven't A, had time, and B, I've wanted to do this video, but to do the video, I kind of wanted to do the entire picture of it. And to show the entire picture of all the hardware and software revisions in history, I needed a bunch. So luckily they're inexpensive, and I've been buying them as they come up on eBay, usually broken or somewhat state of working condition. And now that I've got enough of them here, I can really show that whole picture from the very early versions all the way up to later versions, at least for the 2000 series. The 2500 series I only have one, but that'll be a good demonstration or a good example to compare between the 2000 and the 2500. So these devices had a very long run. The original 2000s, the entire 2000 series, it came out in 1990, and they made them all up into the early 2000s. So they had like a 12 or 13 year run, I believe. And then the 2500, that came out in 1996, and again, had like a 10-year run or something like that, where they were making these units. So as a result, there was a lot of changes over 10 years, both in terms of hardware and in terms of software. And that's some of the things I'm going to be talking about in this video, because it is interesting to see all the different changes they've made over the years, even though they are still all compatible with each other in terms of format, usability, things like that, which is pretty cool to see. So even now in 2020, these things, even though they're 30 years old, up to 30 years old, are still just amazingly powerful and usable pieces of gear that sound really, really good. So as I mentioned, they are sample playback units, but they also are real synthesis engines based on VAST, variable architecture synthesis technology is what Kurzweil calls it, and it's a DSP algorithm based synthesis engine that allows you to make really, really complex sounds. The downside of it is it's extremely complex to use. I've got the manual sets for it here, and and they're just massively thick in terms of all the features that are available for these units. So in terms of this video, or videos as I should say, because I'm sure there's going to be a bunch of them, I'll probably break it up into parts based on what I'm repairing, what I'm talking about here. There's going to be a lot to talk about. One thing, as I mentioned, I'm going to go through the hardware revisions, show the differences there. There was a lot that changed between these units. If you're familiar with these units, you've probably heard about the differences between the Kelvin and Janus hardware revisions. Well, I have one of each in the 2000 series, so I'll be able to actually show what those revisions are between the two of them in terms of the hardware inside. We'll take a look at the rest of the hardware too. I mean, Kurzweil, when they built these units, Kurzweil spared no expense in the actual manufacturing. As an example, for the digital analog converters, they used 80 analog devices, 1865 DACs. Those are debatably still today one of the best 18-bit monolithic stereo DACs ever made. And Kurzweil's got 4 of them in each unit because they wanted discrete DACs for every channel, which is actually pretty impressive for the time, considering the cost of those. And speaking of cost too, I mean, when these came out, they were extremely expensive. Fully optioned out, they cost well over $10,000, and that was back in 1990s money. Today, you even imagine what that would cost today. Luckily, in the used market, like I said, they only usually show up for a couple $100, so they're very affordable. In a working status too, they're not necessarily broken, but they still need some TLC at that point. So the effects are interesting. All the 2000 series has onboard effects, and they're actually using a Digitech DSP-256 effects processor inside there. They essentially just took the DSP-256 by Digitech, the rack unit, and took the circuitry out, put it inside in the main board of this, and that was the primary effects for the 2000 series. Now, when the 2500 series came out, they included the KDFX module, which was a really high-end, high-quality DSP-based effects unit that you could get for these units for the 2500 series and higher. It was expensive option, so you don't always see it. Unfortunately, mine does not have it, but it was available and you can get them. Now, the 2600 series, which followed the 2500 series, had the KDFX module standard. So if you're looking at it and you come across a 2600, which are still pretty expensive, that will already have it, which is pretty nice. In this video series too, I'm going to be talking about all the options you can get for these. There was a ton. You've got program and sample RAM, both upgradable. They use standard, depending on the model and the hardware revision, either 30 or 72 pin SIMs. Hard drives, you could add internal SCSI to these. There was ROM expansions. By default you had the standard ROM samples around here, but you could also buy additional modules. Contemporary and the orchestral were the two that come to mind that you could add additional sounds to these, which some say they're dated, but I still find they're somewhat usable today, and they do sound really, really nice. The sampler option, of course, a very expensive option, but one a lot of people like on these units. You can actually use these as true samplers. Both the 2000 and the 2500 series use the exact same sampler module. There's no difference between the two units. So problems. These units are generally pretty reliable, but they still have a handful of things that go wrong with them over time, especially now being 30 years old, or approaching 30 years old for that matter, depending on what model you have. So first, most common, power supply. There'll be the boring capacitor replacement that's necessary in a lot of these units that I'm going to do, so I'll talk about that. So displays are another weak point in the units. They usually go bad. They were never that bright to begin with, but over time they pretty much fade and you don't have any backlight left. On these units I'm probably going to both replace one of them with a brand new display, and then I'll probably replace the EO backlight strip on one of them as well. Physical problems: buttons wear out, jacks get worn out, need to be cleaned, volume knob can go bad, encoders can go bad, cleaning, just general cleaning going through the unit, I'll be talking about all that. Strangely, power buttons. I've got two units that actually have broken power buttons, and they must be a fragile device, so I'm going to have to replace those. The bottom left unit down here is pretty much a parts unit. It's pretty much been gutted, but it still has a lot of good pieces in there. And one of the reasons I bought it was it's got a really clean front panel with a power button that I'll use to replace on one of these units here. The other one still needs a power button, so you'll probably either 3D print it or mill it out of aluminum. I'll probably just mill it on the lathe, just because it'll look nicer out of aluminum, I think, than a 3D printed version. So I'll be talking about that. Firmware updates, I'll have to go through firmware updates on these. The 2000 series is EEPROM based. The 2500 series is flash based. I'll have to do both. A lot of these have older versions of software, which I know. And depending on if you have the Calvin or Janus hardware revision 2, there's two different ROMs on there for those. And there's also two different sets of ROMs in there, both for the actual setup ROMs, which is your firmware, and then there's an engine ROM as well. So I'll have to check to see if the engine ROMs are all up to date. Other add-ons, you can add SCSI drives, internal SCSI drives to all of these. They have internal fans to keep things cool, which is nice, so I'll probably do that. Floppy drives, I haven't tested these. I've got two units where they're just missing, which they're probably bad. So I'll be putting the floppy, USB to floppy emulators in, a couple of these, just as upgrades on there. For the drives internal, I may not put I don't know if I'll put a hard drive in these or not. If you do, you should be using like the SCSI to SD options for, you're not actually putting a spinning disk in there, but you've got a solid state option basically that runs cooler and is just more efficient. I talked about those pretty much in detail in my Akai S5000 video, if you want to watch that. Other than that, just general cleaning. These things are full of dust. I got to clean the insides, and anything else I may find as I'm going through them. But I definitely want to do a full restoration on these. Get my original two definitely working, back up to spec, and then get the additional two that are mostly complete, working, very in a good state as well. So I'm probably forgetting a bunch of stuff too as I'm talking about these units, but like I said, there's a ton to them, so as I go through it, I'll probably remember things and be able to talk more about them as I go. I don't know how many videos this series will be. It'll probably be topic based, possibly, I don't know, I'll figure it out, but this should be a pretty cool project. So before I start tearing these apart, I wanted to power them up real quick because there's some information about them you can determine just from the display itself as you power them on. So I've got these sorted from the oldest one to the newest one based on serial number. And this top one is actually the one that I've had the longest and I've used quite a bit. So I know the specs of this one. But powering these on, you can get the firmware version right in the display when it powers up. Then you can also see how much memory is installed, both in terms of the program RAM and the sample RAM. So powering the bottom one on. Let's see on the display here. If you can read that, it's a really bad one. So version 3.54 is the actual software version that's currently on here. So this is a Kelvin unit in terms of the hardware revision because it doesn't have a J after the actual version there. They added the J, which I'll show here in a minute, at the end to indicate that it was a Janus version of the hardware. So power up the second one. If I had power to it. There we go. And this one is 3.01, so even older, and also no J. So this is also a Kelvin unit as well. Now, If you're down here, if you look, after it's done initially in the effects, battery voltage is low, 0.0 volts. All these are going to get it, but the batteries are dead that actually back up the program RAM on these, which again holds your actual program settings and things like that you put together in these synthesis units. So those are simply just AA batteries that go in the back, nothing special about it. Kurzweil was smart to do that too, because the RAM in here is power hungry. So if you would use standard 3-volt lithiums like you find in a lot of gear for battery backups, it would drain it really quick, and you'd be swapping that out all the time. So with the standard AA batteries, you can actually just swap those out anytime they go bad. They're only supposed to last a couple years, I think, based on the in the manual from what I read. But in my 2500, it's got the same thing. I've got new batteries in there, and it's been over 2 years and I haven't had an issue. So power on the top one. Again, this is the one that I know the most. 3.54J. So J indicates Janus on this one, but it still isn't the latest version of software. So the latest version of software is 3.87, which I have, and I'm going to put in all three of these. Again, to add that software on here, you actually have to burn it to some EEPROMs and replace the ones that are in there. So you'll lose any current settings you have, so before you do that, make sure you save. So I'm going to go OK on the battery warnings for all three of these. So the next thing I want to show is in the actual menu here. If you go to either disk or master, you can look at the very top. It'll tell you how much memory is in this unit. So sample memory, 8192K, so 8 megs of sample RAM. And then program memory, as long as it's under 128K in terms of what's actually free there, it tells you it's just got the base amount of program memory installed. So there was another 512K module that you could actually put into these to get your sample memory, or I'm sorry, your program memory up to 768K. None of these have that from what I remember looking at them. Yeah, so this one has actually 65, so it's got 64 megs of RAM, which makes sense because it is the sampler version of the K2000. And then again, so only 120K of sample RAM. And then down this bottom one, this has only, so this has 2 megs of sample memory and again 120K of program RAM. So here's the three K2000Rs I've got on the bench. I've got the covers off of them. I'm going to go through the hardware next, just talk about what's inside these things in terms of features, board revision changes, things like that. But I wanted to note on this one, actually, when I took the cover off, there was some notes inside it which were kind of interesting. So January 2019, SCSI labeled dead. So January 29th, 19th, remove hard drive, remove 2 by 16 megabytes of RAM, bank 1. Display showed check some error, but RAM worked. I don't know what that means exactly, so I guess just bad RAM. November 15, 2018, internal SCSI hard drive power disconnected and removed. SCSI controller and K2 board not functional, bad. So they're saying on this one the SCSI controller wasn't working. I'll have to test that. I'm curious. Could be other items related, possibly like this cable being unplugged. I'm not sure. I'll have to check and go through and see, just look up drive to it and see if I can actually get SCSI communication this to work. I want to say I have though, because I have an external drive that I've used on the back. No, I couldn't have been though. Not with that being unplugged. Must have been on one of the other ones I was testing with. But anyway, I'll test that. So let's go through some hardware. So here's the K2000RS. I picked this one because it has a sampler option, so it's got, of all the ones I have, almost the most hardware that's in there. We'll start with the power supply section. So on the back you got your typical input line filter. And then what's really nice about these units is that they are truly world power capable. So this board here, this little daughter board coming off the input filter, it's got multiple, so the transformer up here has got multiple windings on it, and this board changes those windings for the acceptable voltage range for each country. So you got 100 volt, 120 volt, 220, 240. So by simply just taking this connector off and moving it to the correct voltage there, it'll put the taps in the correct order, serial parallel, to accommodate that country's voltage. So no matter where you are, no matter what country you buy one of these from, it will work in your country. You just need to open it up and move this connector if necessary, which is actually really nice. So transformer is sitting up here in the front, just kind of hidden under the display right there. And it's kind of interesting. You can see how it's sitting at an angle. There's no obvious reason why that would be there because they had plenty of room to put it sideways. But it came down to noise that this unit was actually generating, or I should say the filtering for the digital analog converters was picking up was due to this transformer. And whatever reason, the flux lines coming off this transformer, the engineers that designed this decided, hey, if we just rotate this roughly 40-ish degrees, it goes away. So that's what they did. It's kind of funny. They outlined that in the service manual. I found that really interesting. So boards, there's two boards back here that are stacked. You've got your main board here at the bottom. I'll be pulling all these out as we go through these units, and the upper board here. So this bottom board contains your power supply. It's strictly just a linear power supply, a handful of linear regulators and some transistors up here on the front on this nice big heatsink. And then underneath it, as it goes across, you've got there's a CPU there that actually controls, some of the functionality of the unit. You've got the DSP section kind of in the middle here. That's again that Digitech DSP I was talking about. Then on the far right, you've got your digital analog converter section. Those analog devices, converters I was talking about, along with all your filtering and buffering and a couple other items over there too. The second board, this is actually your DSP board. So your engine board, I believe it's called by Kurzweil. So these three chips here are the main DSP of the unit. And in terms of the chips on there, I keep saying there's the Kelvin and Janus versions. This is a Kelvin version. And it's funny because the chipset's made up of two. You have Kelvin and you have Hobbs. I can only imagine that's, after the Waterston comics, that have been popular in the late 80s and 90s, Kelvin and Hobbs. But that's what those are. So the Hobb chips are basically your actual DSP. That's your engine that produces all the sounds and does the sampling, that plays back samples and everything else. And then the Kelvin chip is pretty much some type of I/O chip that's used to transfer stuff back and forth. Now, for whatever reason, it's not really known, this is what changed somewhere in the design cycle, and that's when the Janus version of this board came out, which I'll show here in a minute. And this chip changed, so instead of Kelvin and Hobbs, you have Janus and Hobbs. I have no idea what Janus meant. There was no Janus character in Kelvin and Hobbs as far as I remember, so I don't know, it's up in the air on that. But that's the two real revisions between the units. Now, in functionality differences, they're identical. There is no difference, at least documents of differences that I've ever known or come across, that says that there's anything different about them in terms of the way they sound or the way they work. It's just, for whatever reason, they had to redesign this board with this different chip, made by VLSI, classic VLSI. You saw those everywhere back in the 90s. They were kind of the king of ASICs back then. But they revised it and made it different, and therefore there's a different board, and because of that there was different firmware. So the firmware is in these EEPROMs here. So you got 4 in total. You've got 2, like I mentioned, that are your actual ROMs for the actual unit, which are these 2 here, otherwise known as the setup ROMs. Those are those 2 right here. You can see labeled setup high, setup low. These are the actual firmware for the unit. The other 2 are the engine ROMs. Those are just the ROMs that actually run the firmware for the various DSP and things like that are going on. Now, buried under these cables, you can see the SIMs back here. So this series has got 4 30-pin SIM sockets, and you can see that I've got some old school kind of double stacked, high 30-pin modules back there, along with 2 shorter ones here. Since this is the sampler unit, it does have the 64 megs of RAM. So that's where you would upgrade the RAM in these units. And again, it just takes standard PC, 70 nanosecond 30-pin SIMs. I don't believe they have to be ECC. And they just be standard. So that's where that goes. Back here, if you can see that in frame, yep, you can. This connector is where your ROM expansion goes. So there's a daughter board that stands vertically along here, and it holds 2 ROM expansion cards. So one of the other K2000s has got the orchestral expansion, and then my 2500, a little bit different design inside, we'll take a look at that later. It has both the orchestral and contemporary modules, but they kind of sit in a different orientation on top of that board. Buried under these cables right here, there's an additional connector in front of the ROMs. This is your program RAM expansion. So the program RAM itself is proprietary. It's a module that basically plugs into there, and you can find them, and there's actually a couple companies that make aftermarket modules for this too. They also make aftermarket ROM, factory ROM sets too as well that plug in the back, which is kind of interesting, in the socket back there I mentioned. But ribbon cables too. So it's just kind of a mess in here with all the cables, the way that everything's ran. It gets even worse if you've got a drive in here. So I mean, while not a terrible thing, it does, somewhat impede airflow, and it's just kind of it's one of the kind of things I don't like about them. It just seems kind of crappy that there's just cables everywhere, and there's really no cable management to even clip or tie these down. So when I rip this all apart and clean it and put it back together and do other maintenance, I'm going to try to route these a little bit better, get longer cables if I have to, so I can fold them nice and get them to a proper orientation. I am going to take these outside too and blow all the dust out. They're just a mess. There's dust everywhere inside here. Some are cleaner than others, but it just comes down to, these have a fan, which I'll mention too. So the fans in here are actually pretty reliable. Of all the ones I have, none of the fans are bad. And they're quiet too, so I don't know the exact brand name on it's a Nidec or what, but they seem to be pretty high quality. So with the fan there, it is a good thing, it keeps the interior cool. All the airflow pulls in through the bottom. You can see the holes across the bottom there. It'll drop this side, drop here through the heatsink out the back and across, the various boards in the front there. But it's important when these are rack mounted, you don't have very much space between the bottom and then the next piece of gear if you've got these smashed on top of gear, one on top of each other, which is a problem. So any type of gear like this, typically, because there is no other airflow entrance other than the bottom plate there, you don't want to have these directly on top of each other. What I'll usually do is I'll offset them just by not even one U, just one rack screw in a U. It offsets everything weird in the rack, but it's fine because it allows good air to come through, and keep everything cool properly. So this board along the back is your input-output board, your jack board, for both your SCSI interface and all your analog ins and outs. So there was a revision change that occurred after this unit was made later on in the chain, where they actually added some protection to this board because there was a problem where people were blowing the actual op amps or some of the output driver circuitry down the lower board from static discharge of cables being plugged in and out of this unit. So you'd have dead channels and other issues and things like that. So what they did is they added diode protection basically to this board in a later version. But before they did that revision, there was actually a smaller board that they just glued onto the back of all these jacks and then ran power down and actually just soldered it to some of the pins on one of the regulators here at the bottom. I've got another unit that actually has that. Let me swap that out and show it real quick. So this one here, you can see that board I'm talking about with the actual, all the diodes on there for protection. And then make sure I'm not hidden anything here. Down the bottom, they just tap power off this regulator here. So we needed 12 volts to get it off that 7812, which is kind of funny. So this middle cage here, it holds both your floppy drive down to the bottom, along with any additional drives you would add to this, like a SCSI drive. You would place it inside this cage. Power for the SCSI comes over here at the side. You've actually got a Molex connector kind of tie wrapped up at the side here, hidden down below. So that's where you get your power for the actual SCSI drive. And then you've got a 50-pin SCSI connector here that you would actually run your cable over for the SCSI interface. So again, this is old school, SCSI 1, slow 10, 20 megabyte per second speeds, nothing fancy. You need proper termination for the drive as well. And these older units do not accept very big drives. I want to say it was under a gig possibly for these. I gotta check the specs, 768 meg maybe, I'd have to check. So it doesn't mean you can't put bigger drives in there, it's just it's not going to see it. So in my Kai S5000 video, I talked about hard drives in terms of upgrades for that unit, that sampler, and basically stated why you don't want to use spinning disk drives anymore. It just doesn't make sense anymore, especially now that you can get the SCSI to SD adapters for roughly $70 or so, and they're quiet. They draw very little power. They're solid state. They don't produce any heat. There's just so many benefits to them versus using an old SCSI drive. If you have a bunch of these like I do, I get it. You just want to use them because you have them and they're free. In the Kurzweils, though, there's a couple reasons why you shouldn't use these specifically, and some why they won't even work. And the first is it's space. I checked on space. 2 gig is the max. So, here I've got a 73 gig drive. Even if I put this in here, the most I would get out of this is 2 gigs in terms of what's visible on the K2000. On the 2500, you can actually see a bigger drive in there. I believe it's 4 gigs or something like that. Bigger, regardless. The bigger issue with the 2000 is the power. There's only so many amps that are available both for the 5 volt and 12 volt line, and that's actually outlined in the manual for these units. So if you try to put a drive, especially these more modern, drives in there, modern from the 90s and 2000s, it's not even going to power up in most cases because the current necessary to even power this drive up and start the spindle isn't enough that the 2000 can provide. So usually in that case, it'll just not even turn on. And that goes, you may get away with older drives that might draw a little bit less power and lower spindle speeds, but in that case, even with this drive, I've tried and it won't even power on. So at least for the K2000R, I do not recommend using spinning drive. Get the SCSI to SD option if you want. The benefit of the SCSI SD option too is that you can actually have that set up when you configure it, so that you can have, if say you have a whatever gig size card in there, you can configure it for multiple 2 gig actual drives. And then you can set those to individual SCSI channels. So it'll appear as you have, 4, 5, 6, well 5 in that case amount of drives, which would be the max based on the SCSI standard in there that you could put into the device. So definitely a lot of wins. I highly recommend. I'm not going to be putting a drive into my 2000. I will be putting a SCSI to SD converter in there at some point. Last thing just is real quick is the sampler board hidden over in the side here. So again, this was the option that you could add to any 2000 or 2500 series device, and you basically just knocked out, removed, I should say, the front little panels on there that allowed this to sit in. That gives you your XLRs in the front there along with your TRS connector. There's a couple cables in here you have to route to get audio and digital I/O to certain places, but that's it. You had to have minimum firmware versions available too, which all of these do, and you'd have to upgrade it if you didn't. Again, the sampler card can go into any of them. Even if it's just a standard R unit, not an RS, you can always add the sampler module to it, which is nice and part of the flexibility of these devices. So I'm going to stop this video here. I think at this point I've gone over a lot. Hopefully this wasn't too boring. This is just more of an introduction, an explanation of the hardware and what's inside and the maintenance that needs to be done in terms of all the repair work and upgrades and other items I want to do to these units. So based on everything in this video, you can kind of see of what's going to be up here coming in the next couple of videos. I don't know how many it'll be. I guess it'll just be to be determined, but we'll see. So hopefully this was interesting, and I thank you for watching.